This is the continuation of our graphing or plotting for the 5 points in part A of our grapher, which we did a while ago. And as you can see, okay, we have already plotted the, what do you call this, all the points of our given table. So where's our table? This is our table, and we have already graphed it. Now we connect the points, okay, so that we could finally plot the 5 points in this Cartesian coordinate. Okay, so I'm going to choose this this color. It's a bit red. Okay, and I'm going to graph. So just trace the plotted points. Okay, but I need them also to be somewhat visible. Okay, and I need these points to be visible. That's why I'm covering some of the portions of this curve with a point. Okay, with the plotted points taken from our tabular values here. So in relation to this curve that you see, let's plot the corresponding inverse of, let's say just assume this is an inverse, and we try to confirm this by graphing the opposite or the inverse of that one. So this one, the one that you can see into, will be here, and the other one, the 2.5, will now be here on this and on this part. Okay, and we have for 2 we have 4, and the same is true with our other 2 here. Okay, so actually, if you can see, in the previous slide I told you that it's only 2.5, but as you could see, we also have 4 and 4 here. Okay, so I'm going to graph this now by connecting all of the points here. So I will get something of a mirror of the drawn curve, which lies on the y-axis. Now it lies on the x-axis. The inverse, supposed inverse, lies on the x-axis. And here are the points again. I need them to be visible. And let's draw our y is equal to x line. So let's draw it. This is our y is equal to x. Okay, so in this case, as you can see, let's take off the grids. This curve that we got, the inverse relation that we got, the inverse relation that we got couldn't be invertible, because as you can see, if we take a vertical line, okay, so we have a vertical line here, okay, and let's it has a horizontal line here. So let's show the points here, points, and the points here, and points here, point here, and point here. You could see that in the original function, this is our original function, and this is y is equal to 0.5 x squared plus 2. And this original function would look like this. Let's say supposedly it has an inverse, but you know, this thing, as we saw it, okay, is not really an inverse function. It is an inverse relation. Inverse relation because we could see that for one x value, we have, let's say that's x. In this case, it has, this x is equal to, let's say 3, okay? 3, and then we have a y1, and then we have another 3, and then it's y2. So the 3 here is used twice to get a value for x. And that failed our definition of a function. Therefore, it's not a function, but a relation. Relation, okay? It's a relation. Because what is a relation? It must have a unique value for both x and y, or the x should be unique for certain pairs of points. So this graph here is not, or this function here is not invertible, not invertible. So if that's not invertible, we are still concerned with getting the equation for the inverse relation. And we would like to plot the function f and its inverse on the same screen on your grapher. If you have a grapher calculator, you can easily do this. So how do we get it? Okay, let's begin by doing it algebraically. So we have y here is equal to 0.5 x squared plus 2, and therefore this is our original function. So this is our function. To get the inverse, just interchange x to y. So just interchange the x to y, okay, so that we will have x is equal to, they have the same color. I will have the red. So x is equal to 0.5 y squared plus 2. And then we have to solve for y. So we transpose 2 to the other side. So that this will lead to x minus 2 is equal to 0.5 y squared. And we arrange our placements for the variables. So x minus 2 for comfortability. So therefore, our y squared would be equal to x over 0.5 minus 2 over 0.5. Just divide both sides by 0.5. So our y squared is equal to, that's 2x minus 4. And this will give us y is equal to positive negative square root of 2x minus 4. Okay? By squaring, getting the square root of both sides. So let's take a look. This is our function. This is our inverse function, so as you can see. And then we get this one. Okay? That's the inverse function also. This one. Okay, as we get here. So this confirms this. Okay. Now let me present you the. So how did we get this? What do you call this? y squared is equal to 2x minus 4. That's not yet done. This is our complete step. Okay, so f of 1 of x. This is our f of 2 of x. Okay, now this is on your grapher. Okay, and this will be your f3 of x. And lastly, this will be your f4 of x. So on your grapher, we input on the y menu. Okay, we input this. This is our f1 of x on the y menu. Okay, that's our f1 of x, or that's y1 as we call it, f1 of x. This is f2 of x, which is the positive part of this relation here, and this is our f3 of x, which is the negative part of our relation here. And finally, we have the what do you call this? The boundary or the line y is equal to x, where we define our mirrors, or we define reflections of the functions. So let's now see how this thing looks like, okay? By graphing on the same screen both the function and the inverse of its function. So I have prepared here the graph. Okay. Now let's get rid of this stuff here. Okay. Okay. So our f1 of x is equal to this. This is our original function, with a graph that runs from here up to there. So on your grapher, you can choose any domain. If you have unlimited domain, then it would have to, what do you call this? It would go to infinity. Okay? This one here, the one that you can see, is our f2 of x and f3 of x. Correspondingly, we have 2x minus 4 here. This is the positive part. And we have the negative square root of 2x minus 4, the negative part. Okay, so that completes this parabolic curve here, which opens to the right. And we also have our f of 4, which f of 4 of x, which is just this line. Okay, now this line is needed for us to be able to see the mirrors or the reflection well by putting this line y is equal to x here. Okay, and this one, the line there, actually helps us see whether our graph is really, what do you call this? We could really see more accurately how the graphs are going on. So in this case, they are both mirrors. Look at this. We have our x-intercept here at 2, but on this side we have at y is equal to 2, we have the y-intercept. And it moves here, it opens to the right. This one is opening upwards. So they are reflections of each other across the line y is equal to x. And this is how you graph the whole functions f1 of x, f2 of x, f3 of x, and f4 of x on your grapher calculator. Okay, your calculator is programmed to do this. So you just input all of the values, and then it will show in your graph the corresponding patterns or the lines, the curves, such as in this case we have our inverse and our inverse relation, and we have our original function. So this completes our example 1 for the requirements A, B, and C. On the next lesson, we have another lesson, and it's about parametric equations for getting the inverse and plotting the equations, also the inverse equations, by means of algebra. So thank you for listening. And